Good day, viewers. Welcome to Brainstorm Tutors. My name is Sahid Ogundeji, and what we are having today, we want to look into mathematics, and the topic for today is bearing and distance. But today, we actually want to work on this problem. They ask us to solve these problems on bearing. Then, in order for you to solve any question on bearing, there are two things you need to look into. You have to look at it. The bearing we are dealing with, what kind of bearing is this? By me looking at the question, I know that I'm dealing with three-digit bearing. We also have what we call a compass bearing, and it's just a little distinction between the two. In three-digit bearing, the angular term always begins from the north pole. Like that's the reference point, and it always moves in a clockwise sense. Simply means that it always moves in a clockwise sense, and the angle ranges is between 0 degree is less than theta, and theta is less than 360 degrees, sorry. Then whenever we say that something is a compass bearing, it has two reference points. It can either be from the north or from the south. So if it's from the north, it can either be northeast, northwest, or if it's from the south, it can either be southeast or southwest. And the ranges of angle there is always 0 degree is less than theta, and theta is less than what? 90 degree. That's for the compass bearing. But today we are emphasizing on what? On three-digit bearing. Now, for example, if this is a three-digit bearing, I told you that we always emphasize from the north pole, and from the north pole, my north pole is always 0 degree, but we always write it in three digits, 0, 0, 0 degree. Still simply means 0 degree. Also, my east is always 0, 90 degree. My south is 180 degree. While this south, and my west is 270 degree. And remember, in every geometry we have what we call quadrant. A quadrant is just like dividing the angular term into four regions. So now here, this is my first region. This is my first quadrant, second quadrant, third quadrant, fourth quadrant. We always say that the angular turn is always in a clockwise sense in terms of three digits bearing. And I always move. I mean, the first quadrant, the angle I'm expected there is 0 degree is less than 9, is less than theta, and theta is less than 90. In the second quadrant, we expect 90 is less than theta, and theta is less than 180. In the third quadrant, 180 is less than theta, and theta is less than 270. While in the fourth quadrant, we have 270 is less than theta, and theta is less than 360 degrees, and so on and so forth. Now, the next thing you also have to look at, by men looking at this, they say that a man leaves his house and travels 21 kilometers on a bearing of 32 degrees, and then 45 kilometers on a bearing of 287 degrees. They said, calculate the distance from his house. I mean that the starting points of the man to his final destination, they have to calculate the distance apart between them. And it's very simple. Now, the next thing you have to also look at, which is the second part of it, you have to look at, now, any object or body that always begins from the first quadrant, its destination is always in the what? In the third quadrant. Always remember this. First quadrant, we arrive at third quadrant. I mean that odd to odd, even to even. That means that any object that begins from the second quadrant, its destination is going to be in the fourth quadrant. I'm going to use this. Once you know these two facts, you can solve any problems on bearing, and you can have a good diagram wherever you are solving a bearing problem. Let's go with this question. It said, a man leaves his house and travels 21 kilometers on a bearing of 32 degrees. Remember, 32 degrees fall in the what? In the first quadrant. So if the man is starting from the first quadrant, his first destination is going to be in the what? In the third quadrant. Like this. I've informed you earlier that we always begin from the north pole. Then we have something like this. Let me call this point S, which is the starting point. The first point, the man arrived is point B, and then the angular turn is 32 degrees. Here, so it then starts from point B also and move on a bearing of 287 degrees. If you look at 287 degrees, it falls in the fourth quadrant. So its destination is going to be in the what? In the second quadrant. I told you it's vice versa. Anything that begins from second quadrant is destination in fourth quadrant. I can also say that anything that begins from the fourth quadrant, its destination is going to be what? In the second quadrant. It's vice versa. So now here, these angles fall in what? In the fourth quadrant. So that's how we have something like this. From here to here is what? This one is 287 degree. And here is what? 32 degree. Now here, I told you that the destination is going to be in what? It's going to be in the, let's assume this point is point A. That's the final destination. So, and then what we have here, we say that this one is point A. And here, the distance here is 21 kilometers. Don't forget, I make this one longer because you can see 21 kilometers is lesser than 45 kilometers. 45 is more longer compared to this. So in your diagram, you have to include that so that they will know that you know what you are doing. So we have this is 45 kilometers. And remember, this is a bearing involving 3 points. So that's mean any bearing involving 3 points almost always form what we call the triangles. Now, here, this is 21 kilometers. This is 41 kilometers. And whenever you are solving a problem like this, you always begins your third point destination from the longest side. You can see 45 kilometers is more than this. So I always begin my point. So anything that is coming from what? From the second quadrant, its destination is going to be in the fourth quadrant. So my drawing will look like this. Make sure that your drawing is very neat. You can draw with a ruler and use a pencil during your drawing. So now, here, you now need to solve the distance AS. That means that the distance of the man from his starting point. This is the starting point, this is the final destination. I need to look for the distance AS. So here, I need to apply either sine rule or cosine rule to solve my problem. But we don't know the one to apply there, depending on what we have from the diagram. That will determine the kind of rules we are going to use. Now, from what we have here, there are some hidden things that we need to look for, even they don't ask us, but we need to get it. Like here now, if from here to here is 32 degree, from geometry, from here to here is also going to be 32 degree. Let me assume that this space is x degree. Remember, we just need to look for all those sides. So here, I'm going to say x degree equals to 32 degree. You ask the reason, alternate angles are equal. So now here is what? This x is what? Is 32 degree. I have 32 degree. Also, there are also other things. Remember, every quadrant is 90 degree. Here is 90, 90. So now, I now need to, because before I can solve this side that they ask us to find, this AS, I need to know this angle B that we have here. Let's assume this is angle B. I need to look for it. Then, and for me to know, I know that the angle B plus this plus 90 will give me 287 degrees. So I just have to do the geometry calculation. B plus x plus 90 equals to 287. Please let us be fast with this. I have B plus, this is 32 plus 180 equals to 287. Then I have B plus, this is giving me 212 equals to 287. And then B is going to be 287 minus 212. Then B equals to, this is going to be 5, that's 75 degrees. So B is going to be 75 degrees. Now, we have been able to get this. So I remember, if you are applying either sine rule and cosine rule, after we know the included angle, we know that the side that is facing that included angle is always a small letter. So why the included angle is always a what? A capital letter. So if this angle is capital letter B, the side that's facing is going to be small letter B. But if this angle here is capital letter A, the angle that's facing is going to be what? Small letter A. I mean, the side that's facing is small letter A. But if this angle here, the whole of this angle, remember, this is not the whole of this angle. If this whole of this angle is capital letter A, the side that's facing is small letter S. So that's all about that. So now let us now look for this. We have gotten this angle, so we can use this side to solve for the value of my A. So I'm going to apply cosine rule here. Remember, cosine rule states that if we have two sides and an angle, we have included angle between the two sides, we apply cosine rule to find the opposite side of that included angle. So now here, I'm going to apply what? I'm going to apply cosine rule to find this. Now, to use cosine rule, I'm going to have b squared, since it's this side I'm looking for AS. B squared equals to AX, A squared plus S squared minus 2AS cos B. Cos B. So now I'm going to just continue. I have B squared equals to, what's my A squared? My A squared is 21 squared plus my S squared is what? 45 squared minus 2 times 21 times 45 times cos 75 degree. So you can just use your calculator to make the work so fast. 21 square will give you what? So sorry. Now here, if I continue, I have b square equals to, if I sum up all this together, I have 2025 plus 441. I have 2466 minus, remember, Bodman's multiplication come before what? Before subtraction. So I'm first going to multiply this and this together. I have 1890 multiplied by 0.2588. I have 489.132. So now, if I take away this from this, what am I going to have? I will just say minus 2466. I have it to be 1976.868. So now, when square is going to the other side, we're going to square root of what? 1976.868. Then, when you have that, what's square root of that? We have square root of 1976.868. Then we have 44.46 kilometer. So let me just leave it to two decimal places like that. So the distance here is what? We have it to be 44.46 kilometer. So that's all about that. So we have been able to get the distance of the man from its starting point. That is my A. I'll solve for my A. So the second part that they asked us to solve for, they asked us to look for the what? That's for that. They have to now look for the bearing of the what? Of the man from his starting point. Now, this is where many students usually get confused. Calculate the bearing of the man house from his final position. So remember, this is where the man is. This is the final position of the man. This is where is the starting from. So now, the bearing of the man house from his final position. So it begins from the final position. The bearing begins from the final position. We now want to look for the angular turn from the final position to his starting point. This line is the line that connects AS, the man final position, from his starting point. So we are going to look for the angular difference from this angular distance from this final position to its what? To its starting point. So I'm looking for this angular turn in a clockwise way from here to this line AS. So now we don't know. Before we can know that this angular turn, let me call it phi. Before you can know this angular turn phi, which is the bearing of the man house from its final position, I need to know this angle A. And how can I get this angle A? I can apply cosine, I can apply sine rule. Here I apply cosine rule. Here I can, in order for me to get this angle A, I can apply, let me just apply sine rule. Actually, I can still apply cosine rule too, depend on you. So let me just apply sine rule. I will just say sine rule states as sine A over A equals to sine B over B. I can actually use that. I'm using sine B over B since I know the angle of B. I also know its side. So that's why it's very easy for me to do that. I know the side of A. I can easily find the included angle. So here I can now say that sine A is equals to A sine B over B. I just do change of survey formula like that. So I know my A. My A is what? Is 21 kilometers. I'm just going to say 21 times sine B. My B is what? Is sine 75 degree over B. My B is what? Is 44.46. So I can now say that my sine A, I'm just going to use the calculator here. I have 21 times, I'm going to look for sine 75. I have it to be 0.965. Always give it to 4 decimal places over 44.46. So if I do this, sine A equals to, I multiply this by, that is 21, multiplied by 0.9659. I have it to be 20.2839 over 44.46. So I'll divide it by 44.46. I have it to be 0.4562. So now, in order for me to get my A, I'm going to have sine inverse of 0.4562. Then I'm going to have sine inverse of the answer I have. Sine inverse of the answer I have. Then I have it to be 27.14 degree. So the angle A I have here is, this angle A is 27.14 degree. So now let me just use it here like this. Let me just say this is 27.14 degree. Sorry. So this is my angle A. Always remember that too. This is my angle A equals to 27.14 degree. I've gotten it here. So now, before I cannot get this my bearing, this angle phi. Remember that the angle that we have from here to here is 90. Remember that. So I now need to look for the angle I have from here to here. We have here the angle from here to here. Then how can we get this angle? It's very easy. If you look at this angle and this angle, they are alternate to each other. And how can I get this angle we have here? I can just say that these angles here can be, we have used x. Let me call this place y, and let me call this place z. So now, in order for me to get this angle y, we all know that if from here to here is 32, and from here, we all know that the angle from here to here is 90. The angle from here to here is 90, and from here to here is 32. So the angle here is going to be, we have 58 degrees. And if this angle here is 58 degrees, 75 minus 58 degrees, then y is going to be equal to 17 degrees. I'm just trying to be very fast with this. Then if y is 17 degrees, y is going to be equal to z, which is equal to 17 degrees, which is alternate angle. Now to get this bearing, so the bearing is going to be phi is equals to the sum of total angle we have from here to here, which is 90 degrees plus z plus a. Remember, we have find a before, that's 90 plus z. What's my z? My z is 17 degrees plus a. My a is 27.14. That's 0.14. So now if you just add it, 90 plus 17 will give us that is a 107. 107 plus 27. We have 4, 2, 3. That's 134. 134.14 degrees. So therefore, the bearing, just so that the bearing of the man's house from his final position is 134.14 degrees. So that's all about that. Thank you for watching. Don't forget to like, comment, and follow. Bye.